mesh them together in line like this, or you can do it at a 90-degree angle. Hi, welcome to the Mentored Engineer. I'm excited about this episode. We are going to talk about gears, and in addition, we get to talk about Legos. Woohoo! Love Legos. All right, so first thing I want to mention about gears is they are not sprockets, and sprockets are not gears. All right, gears, they mesh with each other. You can see here that these two go, and they will mesh in opposite directions. When I turn my Lego gears into Lego sprockets, they will turn the same direction at different speeds, of course, because they have a different number of teeth. But sprockets go with chains, gears mesh with each other. Okay, so Lego has done a tremendous service to themselves by making their gears and their sprockets the same thing. They've multi-purpose something. And that's great because they don't have to worry about efficiency necessarily or tooth strength. So pretty good move on their part. Kudos to them. Okay, so I've got a bunch of gears here that I just want to show you what they are. And the first of these are Spur Gears. And I've got 4 different Spur Gears here. We have 8 tooth, 16 tooth, 24 tooth, and 40 teeth. And they all will work together with each other. They all have the same diametrical pitch, which we'll get into in a second. And that allows the gears to mesh with each other. All right, and all gears have the same diametrical pitch in the Lego universe. Okay, so now we have some cool versions of gears. This is a rack gear, and it is used, it's basically just a gear that has been cut and flattened out. It has the same diametrical pitch as a round gear, except rack gears don't have diameter, so they kind of fudge that a little bit, and they just keep the same diametrical pitch, the same distance between each tooth, even though it essentially has a radius of infinity. All right, and if you've ever heard the term of rack and pinion, this would be a rack, and a small gear, usually one that drives something else, is called a pinion. So this is a rack and pinion system. Now you probably have heard this term as far as rack and pinion steering, and I want to demonstrate with you real quick how that works. So here's the front end of a car, and you can see I have a small pinion gear and I have a rack gear, and I have some steering arms, and then I have my front axles. All right, and all this does is when I turn the steering wheel here, it moves the rack relative to the pinion, and it shoves it side to side. And that's all we're doing when we have rack and pinion steering. Pretty simple. All right, another gear here is a worm gear. And a worm gear is meant to interface with another gear at a 90-degree angle. So as generally, this gear is the driven gear, and the worm gear is the driving gear. As we turn it, we only get, for every 1 revolution, 1 indexed tooth on this gear. Now, depending on how you design this, you can actually get great interface between the 2 gears, so that you're not just wearing on 1 tooth here and 1 gear here. Now, granted, there will be 1 area of the tooth on a worm that generally gets a lot more wear than any of the other teeth. Obviously, the ones on either end pretty much don't get anywhere. Okay, the next thing is a mitered gear. Now, a mitered gear has the teeth, and you can see that they are cut on about a 45-degree angle, and that's so that you can interface with 2 of them and form a 90-degree angle. I'm going to try to hold them so you can actually see. We'll probably zoom in here too. Yep, there we go. And you can change the direction from being in the same axis to being 90 degrees apart. And that's a mitered gear. All right, and then we have another form of that too. This is more of a cog gear. I just want to throw it out there. This is what you'd see, a long time ago, you know, medieval times or something like that, where they'd have two things meshed together. These are very inefficient, and they pretty much have been totally replaced by a rack gear. And they also, you can actually use this in two ways. You can, I imagine that if Legos would allow you to, you could mesh it together at just about any angle up to 90 degrees. So from 0 to 90 degrees. All right, so some gears that Legos doesn't have are helical gears. And they are basically spur gears, and spur gears have essentially a 0 helical angle. All right, the teeth just go across. All right, and that's great. But what happens is when you get up to high speeds, they start making noises when they interface with each other. You may have noticed this if you have Legos yourself. A helical gear cuts the tooth at an angle so that there is always a shifting in motion instead of one tooth letting up and another tooth getting on. If you have a standard, if you have any transmission, they use helical gears in there because they are very quiet. If you have noticed in a manual transmission car, if you go in reverse, there's a whine. And that is exactly because the reverse throws in a set of spur gears specifically for that purpose. Little more on the helicals. When you cut them at an angle, as you make contact between the gears, the contact actually will start on one side of the gear, on one side of the tooth, and actually move across to the other side as it goes through. And that gives us a nice constant line of contact between the two systems. So very nice. Lego doesn't have anything to go with that, and I don't anticipate them wanting to do that anytime in the future. Okay, so the last thing I have to show for you today is a differential. And we'll talk a lot more about this, but essentially a differential is a system of gears. There's 4 gears here. They have it as 5. Basically you have your driving gear here, and either one of these two will drive this housing. And then you have 3 mitered gears. And basically how it works is your drive chain will turn this, and these will stay stationary. All right. Now when you go around the curve and let's just say you're making a right turn, so we're going this way, this tire will move less than this one, and that's what a differential allows you to do. It allows the 2 wheels to spin at different rates. So gear teeth are designed with a unique profile, and it's called an involute profile. And basically what it is we are taking a string and wrapping it around a cylinder and tracing the curve as it unwinds. So when I start off here, I'm going to use this cup and this dry erase marker, but I'm going to do that, and I get this curve, and it'll kind of go forever. And depending on the diameter of the cylinder that we wrap around and the curve is what kind of profile we get. Now, I don't know all the specifics of this. Somebody has thought this out, and they've done a lot of careful planning, a lot of calculation. So, you know, let's leave that to the experts and just go on their theory and know that it works. Okay, so generally speaking, we have different pressure angles. And these pressure angles, the standard ones are 14.5 degrees, 20 degrees, and to a lesser extent, 25 degrees. All right, with these moving from coarse to fine. Now with the coarse ones, we're interested there in a lot of power transmission. These are precision gears. They want to have very little backlash. One of the things that's important as you get with higher and higher pressure angles is the distance center to center gets a lot tighter. We're going to talk about that more in our next video. So please stay tuned for that, and we hope to you will join us for that. Thanks. Bye.